everyone. In the last class we discussed how to find the inverse Laplace transformation by the first method, partial fraction method. Today I am going to do with another method for finding the inverse Laplace transform, and the method is by integral theorem. The inverse Laplace transform by integral theorem. See, we have the integral theorem. This theorem I already discussed. The theorem says if L f of t equal to f of s, if Laplace transform of function f of t is f of s, then Laplace transform L of integral 0 to t f of u du equal to 1 by s into f of s. See, this thing I discussed already in the earlier class. Laplace transform of the integral 0 to t f of u du, this is equal to 1 by s into f of s. Then suppose we are taking L inverse on both sides. Suppose we are taking L inverse on both sides. See, L inverse of L of this equal to L inverse of 1 by s into f of s. See, L inverse of L, this get cancelled. So, LHS reduces to integral 0 to t f of u du. That is equal to L inverse of 1 by s into f of s. Now you read from this side that I wrote here. L inverse of 1 by s f of s equal to integral 0 to t f of u du. This is the second method for finding the inverse Laplace transform. So what it says actually. See, in order to find inverse Laplace transform of these types of functions, see what is the speciality of this function? F of s is multiplied by 1 by s into something. If your function is of the form 1 by s into something, its inverse can be calculated by the integration technique. How? It is integral 0 to t f of u du. See, what is f of u? How do you get f of u? We know f of s. F of s means it is Laplace transform of f of t. Okay, so from f of s, you calculate f of t. Find f of t. How? Just find the inverse. So that gives f of t. And you rename, instead of t, you put the name u. So you'll get f of u. Okay. So first fix the function f of s. Find its just inverse f of t and rename t by u. You'll get f of u. And this function is integrated from 0 to t. Okay. This gives the inverse of 1 by s into f of s, and this is the second, we can call this as the second method for finding the inverse Laplace transforms. Now look at the first example. Evaluate L inverse of 1 by s into s minus 1. L inverse of 1 by s into s minus. See, you can do this question by partial fraction method also. So, how can we do this question? By integral theorem. That is that we are examining here. Okay. See, this according to this theorem, L inverse of 1 by s into f of s. See, 1 by s, the coefficient of 1 by s is f of s. Okay. So, here in the place of capital F of s, what we have? See, in the place of capital F of s, we have 1 by s minus 1. So, that one f of s you can write here. F of s is equal to 1 by s minus 1. So, this question is of the form 1 by s into something. Okay, 1 by s into f of s. So, by the integral theorem, the inverse is integral 0 to t f of u du. So, our aim is to find f of u first. Okay, so I wrote here by the theorem it is integral 0 to t f of u du. Now our aim is to find f of u. How will you get f of u? That you can calculate from capital F of s. From capital F of s, f of t is equal to, f of t means just inverse of this. So L inverse of 1 by s minus 1. L inverse of 1 by s minus 1 is e raised to t. Okay, this is f of t. F of t is e raised to t. So what will be f of u? Just rename, okay, t as u. So f of u is e raised to u, and you substitute in the place of f of u. So integral 0 to t e raised to u du. Okay, e raised to u, we know the integral is e raised to u itself. from 0 to t. So okay, that is equal to, put the upper limit first. So in the place of u, you put t. So a raised to t minus the lower limit a raised to 0. So this is a raised to t minus a raised to 0 is 1. So the final answer is a raised to t minus 1. This is the final answer. Okay. Now look at the next question. L inverse of 1 by s square into s minus 2. 1 by s square into s minus 2. In this question, first we are considering L inverse of 1 by s into s minus 2. 1 by s square into s minus 2, its inverse we should find. But before that, you consider L inverse of 1 by s into s minus 2. So this is of the form 1 by s into something. That something can be, you can name that something can be f of s. Okay, so in the place of capital F of s, we have 1 by s minus 2. Therefore, by integral theorem, 1 by s into f of s is integral 0 to t e raised f of u du. And what is f of u? F of u is, see, from f of s you calculate f of t. F of t is L inverse of 1 by s minus 2. That is a raised to 2t. F of t is a raised to 2t. Therefore, f of u is e raised to 2u. Okay. So, this in the place of f of u, you can put e raised to 2u. So, e raised to 2u, its integral is e raised to 2u by 2. So, when you are substituting upper limit, it is 1 by 2 can be taken outside. E raised to 2t minus e raised to 0. E raised to 0 is 1. So, 1 L inverse of 1 by s into s minus 2 is 1 by 2 into e raised to 2t minus 1. Now, you will take L inverse of 1 by s square into s minus 2. This is our question. 1 by s square into s minus 2 can be written as L inverse of 1 by s into 1 by s into s minus 2. So now again this is of the form 1 by s into something. This something can be substituted as capital F of s. So in the new case, capital F of s is 1 by s into s minus 2. Therefore, by integral theorem, its inverse is integral 0 to t f of u du. What is f of u? F of u, will get f of u from capital F of s. From capital F of s, f of t is just inverse, L inverse of this. What is it? It is the previous answer. Okay, previous answer is 1 by 2 into e raised to 2t minus 1. In this you put t is equal to u. So, f of u is equal to 1 by 2 into e raised to 2u minus 1. And this can be substituted here. Therefore, we should integrate the previous answer in terms of u. Integral 0 to t 1 by 2 into e raised to 2u minus 1 into du. Now, we should integrate this function. Okay. So, integral 0 to t 1 by 2 into e raised to 2u minus 1 into du. On integrating 1 by 2 can be taken outside. E raised to 2u, its integral is e raised to u by 2. Remember, in integral, the coefficient should be divided. So, e raised to 2u by 2 minus 1, its integral with respect to u. 1 on integrating will get u. Okay, with the limit 0 to t. Now, you put upper limit, then lower limit. Okay, upper limit minus lower limit. So, this is 1 by 2 into e raised to 2t by 2 minus t. This is upper limit minus, on putting lower limit 0, in the place of 0 when you are putting u is equal to 0, e raised to 0, that is 1. So, 1 by 2 minus u equal to 0. So, only 1 by 2. Therefore, the final answer is 1 by 2 into e raised to 2t by 2 minus t minus 1 by 2. Okay. Now we have the third problem. Evaluate L inverse of 1 by s square into s square plus a square. 1 by s square into s square plus a square. In this question, you just start with the 1 by s into s square plus a square. See, we should get 1 by s square into s square plus a square, but we are starting with 1 by s into. Okay. Then in 2 steps, we have to find the inverse. Okay, so let us start with 1 by s into 1 by s into 1 by s square plus a square. See, this is of the form 1 by s into capital F of s. In the place of capital F of s, what we have? Capital F of s is equal to 1 by s square plus a square. 1 by s square plus a square. Therefore, by integral theorem, it is integral 0 to t f of u into du. And what is f of u? F of u, for finding f of u, start with f of t. F of t is L inverse of 1 by s square plus a square. That we know it is 1 by a sin 80. Okay. Now you substitute f of t is 1 by a sin 80. Therefore, f of u is 1 by a sin au. Right? Therefore, in the place of f of u, what we can substitute? It is 1 by a sin au du. Now sin au on integrating, it is minus cos au by a. 1 by a, I have taken 1 by a outside. Okay, so sin its integral is minus cos, and in integral the coefficient should be divided from the limit 0 to t. So first put upper limit, then the lower limit. Therefore, what we will get? 1 by a into 1 by a, this is 1 by a square. So on putting upper limit, it is minus cos 80. Okay, minus cos 80. And on substituting u is equal to 0, you will get cos 0. Cos 0 is 1. That is positive. Okay, so it is 1 by a square into 1 minus cos 80. So what we obtained actually, it is not the given question. L inverse of what we obtained, it is L inverse of 1 by s into s square plus a square. Whose inverse we obtained? The inverse is 1 by a square into 1 minus cos 80, right? Okay, now we should find 1 by s square into s square plus a square, its inverse. Okay, so what we have to do next? Again treat this as 1 by s into this one. 1 by s into something. Again one more time you have to integrate. So in the next step we are integrating this answer. Once more we are integrating. Okay. We obtain L inverse of 1 by s into s square plus a square as 1 by a square into 1 minus cos 80, right? Therefore, L inverse of 1 by s square into s square plus a square, this can be written as L inverse of 1 by s into 1 by s into s square plus a square. See, on multiplying s into s, you will get s square. But this is of the form, see, this is of the form L inverse of 1 by s into something. If it is 1 by s into something, surely you can apply integral theorem. Okay, so in the place of capital F of s, what we have? Capital F of s is 1 by s into s square plus a square. Therefore, by integral theorem, this is integral 0 to t f of u du. This is by integral theorem. We should substitute f of u. From where? F of u can be calculated from capital F of s. From capital F of s, f of t is just the inverse. L inverse of 1 by s into s square plus a square. But this we calculated in the first section. Okay. So the inverse is 1 by a square into 1 minus cos 80. Therefore, f of u will be 1 by a square into, that I wrote here, 1 by a square into 1 minus cos au into du. Now just integration. 1 by a square can be taken outside. 1 on integrating with respect to u, it is u. Cos integral is sine. So cos au is sine au by a with limits 0 to t. So substitute upper limit, then lower limit. On putting lower limit, everything will be 0. So on putting upper limit, what we have? 1 by a square into t minus sine 80 by a, and this is the final answer. Okay. Now another important problem. Evaluate L inverse of 1 by s into s plus 1 whole cube. 1 by s into s plus 1 whole cube is of the form 1 by s into something. That something can be taken as 1 by s plus 1 the whole cube, so that you can apply integral theorem. By integral theorem, it is integral 0 to t f of u du. So we need f of u, isn't it? See, in the place of capital F of s, it is 1 by s plus 1 whole cube. Therefore, what is f of t? F of t is just the inverse of f of s. See, how do you find the inverse of 1 by s plus 1 whole cube? There, you look at the denominator, there is a shifting, isn't it? S is shifted to s plus 1 and its cube. When s is shifted to s plus 1, the function should be multiplied by e raised to minus t. This is by first shifting theorem, right? So, s plus 1, since the s is shifted to s plus 1, I wrote here e raised to minus t by first shifting theorem. Okay, therefore the remaining is, instead of s plus 1 whole cube, we have only L inverse of 1 by s cube, right? Therefore, the inverse is e raised to minus t into 1 by s cube, its inverse is t square by 2 factorial. We discussed L inverse of 1 by s raised to n plus 1, right? This is f of t. We should substitute f of u. In terms of u, everywhere in the place of t, you rename it as u. Therefore, integral 0 to t, e raised to minus u into u square divided by 2 factorial into du. Now, we should integrate this function. See, 1 by 2 factorial means 1 by 2, it can be taken outside. Look at the remaining function. This is a product. You can apply Euler's principle, or I will tell you an easy method for integrating these two functions. See, this is algebraic function and e raised to u minus u is exponential. So, you can do the integration in an easy manner. You first take the first function as the algebraic function. Always the first function as algebraic function, and take exponential as the second function. Then you apply the rule. It is almost the same as your Euler's rule, integration by parts. Okay, first function u square, first function into, you put each and every term you denote in a simple bracket. So first function u square into integral of second function e raised to minus u, its integral is e raised to minus u by minus 1 minus, see, the next term is actually the derivative of u square. You put it as in one bracket. So u square derivative is 2u in one bracket, and without changing the sign, write the integral again. Integral of the second function e raised to minus u by minus 1, the total integral, it is e raised to minus u by minus 1 minus 1. So it is only e raised to minus u plus. Each term you have to arrange in a particular bracket and don't do any simplification. That is the procedure. Now again 2u is derivative. It is 2. Put it in one bracket. And again integral of next term e raised to minus u by minus 1. So integral, derivative, integral, derivative, integral. And look at the sign. The first term is positive. Second term is negative, third term is positive. Like that you can arrange the different terms from 0 to t. Okay. Now on substituting upper limit everywhere, instead of u, you substitute t and minus the lower limit term u is equal to 0. Therefore, when you are substituting lower limit 0, all the terms except the last term is 0. Okay. So the last term when you are putting u is equal to 0, this is e raised to 0, 1. Okay. So we have minus 2. So on simplification, what will you get? It is 1 by 2 into 2 minus 2 e raised to minus t minus 2t e raised to minus t minus t square e raised to minus t. And this is the final answer. Thank you.